All right, this video is going to walk you through how to use a protractor and also understand how polygons' central angles relate to the number of sides. The first thing you need to do is know how to use one of these guys. This is a protractor. It's got numbers on the inside that go from 0 to 180, and it also has numbers on the outside that go from 0 to 180. The reason why they put it on both sides is sometimes you put the side on this, the angle side on this side, and sometimes you turn it this way and you put it on this side. So depending on which side you pick to choose, it might differ on what set of numbers you're going to choose. If the angle is what we call an acute angle, smaller than 90 degrees, then you want to make sure you're reading the numbers that are off here that are smaller than 90 degrees also. So if we're going to measure this angle, you take this little T that you see here and you put it right at the vertex of the angle. So at where the vertex is at angle A here, I place it right there. And now as I zoom in on my screen here, you're going to notice that I've got this angle and it looks like it's almost 30 degrees, but it's not. It's just a little bit short of that. So let's just say that's about, let's say 31 degrees. So I just used my protractor and got 31 degrees. You might be tempted to say the other angle that you're seeing there, you might be tempted to say that that's 148 degrees or 149 degrees, but you want to use the smaller angle because this is an acute angle. Now, if I go to this next angle over here, and I measure this second one right now, I put my line, one edge of the, see how there's a T here on the protractor. This little T right here, one of the sides of the angle have to be on that T. So I'm going to choose to put this side right here on the B, put it nice and carefully straight along there, and then measure that. You'll notice that this one comes out here right at about 55 degrees, but that's not 55, that's 55 this way. I have what's called an obtuse angle where it's larger than 180 degrees, or larger than 90 degrees, and that becomes 125. As you can see, I've got these inside angles going 10, 20, 30, and so on, all the way to the 120, and it's halfway between 120 and 130. That means that's probably going to be 125, so 125 degrees. That's how you use a protractor. Hopefully that's already familiar to you from before, but if it isn't, that's how you do that. Either an obtuse angle bigger than 90 or an acute angle less than 90. And if it is 90, then obviously it would be what we call a right angle. Now, as you go to the next part, I'm going to be asking you questions about how many degrees are in a circle. If you have a circle and I got out my protractor, this protractor only does 180 degrees. So if you have two of those together like this and add up all the degrees, you're going to have 360 degrees. So there are 360 degrees in a circle. Next, if I had 30 degrees and I asked you how many of these would you fit around the entire circle? Well, the math skill you would try to use with that is take your calculator and say, well, I know the whole circle has got 360 degrees in it. So if I do that and I say, well, how many 30-degree angles fit in a 360? Take 360 divided by 30, and you get the answer of 12. I could fit 12 of these angles around the circle. Okay, that's how it works. So the way I got that answer again is I take 360 degrees, and I'm going to say how many of these 30-degree angles fit in there? I divide by 30. And that's how I get the answer of 12 angles. Okay? Now, let's try to do the next one. If I ask you how many angles, or how many 45-degree angles fit in a circle, well, I can draw one of those out. It looks like this. There's about a 45-degree angle right here. And if I ask you how many of those fit in there, well, there's one there, there's one right there, there's one right there, and there's one right there, and there's one right there. There's a total of 1, 2, 3, 4, 5, 6, 7, 8. There are 8 of those 45-degree angles that fit there, right? And if that's the case, if I take 360 divided by 45, and if you didn't trust yourself and you used a triangle that said how many of these 45-degree angles fit in a 360, let me do that here too. 360 divided by 45, whoops, I didn't do the divide key, divided by 45, I get the answer of 8. I can fit 8 of these 45-degree angles in there, so 8 angles fit around that. Now that skill I'm using will help us determine what kind of polygon we have. There are 12 polygons you need to be aware of in this lesson today. Here they are. We've got a triangle with 3 sides, a square with 4 sides. These should already be familiar to you. 5 sides is a pentagon, 6 is a hexagon, 7 is a heptagon, 8 is an octagon, 9 is a nonagon. That's a newer one maybe for you, maybe. Decagon has 10 sides. It's called a hendecagon. I know our homework will probably just say 11gon, most likely. And then if you got 12 sides, we call that a dodecagon. Those are your 3 sides 3 through 12 polygons you need to know the names of. Now, as I say these names, you need to know the number of sides that go with them. So if I say decagon, you're thinking 10 in your background of your mind. Now, in a triangle, for example, if I had this cut up into angles like a circle is going to have, I could make how many pie pieces? There are going to be 3 pie pieces in this triangle. This little angle that's formed on each of those pie pieces is called a central angle. central angle. Now, I'm going to abbreviate that. Central angles are going to be formed right with the center of the shape. Now, if I ask you how many degrees are in that central angle, well, if there are 3 of those, if I ask you how many degrees are there in each of those angles, and I know the whole circle of angles of all 3 of these added together, they need to equal 360. So if I take 360 and divide that by 3, 360 divided by 3 is going to give you 120. That means each of those pie pieces have to have 120 degrees for their angles. So this is 120, this is 120, and this is 120. Now, if I asked you on a square, what is that going to have? Well, a square, if you take 360 divided by 4, I'll just do a couple more of these to show you how these work. Take 360 divided by 4, and when you look at that one, you get the answer of 90. And sure enough, that already makes sense. That looks like a 90-degree angle for that pie piece. Now, remember, a square is going to have 4 sides, which then means it has 4 pie pieces. If you have this one right here, it has 5 pie pieces for a pentagon. So all you would do is take 360 divided by 5, and your calculator would say 72 degrees. And as you keep going, you can go all the way up to this, and you might ask, well, how many degrees are in a dodecagon? In a dodecagon, if you take 360 and you divide it by 12, the answer is going to equal 30. That's the very first question I asked you on the yellow sheet when I said, wait a minute, how many 30-degree angles fit into a 360? That's 12, which then means when I say how many 30s fit into 360, that means you have a dodecagon because the answer is 12. And if you take 360 divided by 12, that tells you the number of degrees in each of these angles. So however many sides you have, whether it be 11, 10, 9, or whatever it might be, take 360 divided by the number of sides, and that will tell you what your central angle is. So I did this one right here, and I measured that one out with my calculator. That answer is going to come out to be 30, it's kind of a weird answer here, 32 degrees, or 32.7 degrees on ones like that. And that's how those work. So really, I hope this helps, and good luck as you move forward on trying to find your central angles and the number of sides.